Recording. Okay. Hi. So, welcome to the reading group session today. We're going to review the paper called Where Should Saliency Models Look Next? And this paper will be presented by Junting Pan. So, Junting, the floor is yours.
Okay. Just welcome to my talk. And the topic for today is called Where Should Saliency Model Look Next? With a question mark. So, hello, I'm Junting, and I'm here to give the presentation today. Just to give a brief introduction about what is saliency map. Saliency map is a probability distribution map that describes where human observers look into an image. It can provide important clues to image understanding, such as the main focus of human attention, or even what's happening in the image, and also who are in the images. Well, so that's we call regions of interest to us, to humans. And let's start with the first set of slides about the motivation of this work. Recently, there's a breakthrough because in saliency matrix, just because the score increment has been stable for a very long time since the CNN comes, the convolutional neural networks. And many of them try to do it in an end-to-end manner. They're doing the feature extraction, feature integration, saliency prediction all together. And the effect is that evaluation scores have begun to saturate. It cannot improve anymore. And we have the question that's the main idea of this paper that tries to justify is that have the saliency model began to converge to human performance, and is saliency a solved problem? So let's see how the author gonna to answer these questions. And effectively, there's not. I mean, saliency prediction models still lack of higher level concept that we call maybe text, object of gaze and action, location of motion, and people in image. And well, to justify why there are lack of this higher concept, let's see a picture that was 4,000 words. And so it's this one. And maybe you can see we just classify the image by a couple of categories, and we can see that the yellow circle just try to circle the missing part of the saliency models. In this case, the saliency prediction does not do a good job in predicting text, action, and people, and main focus in this case. Let's check some related works and the evaluation matrix about saliency prediction. Well, the best model in MIT 300 benchmark is called, there are two best performance. A Silicon model who use two CNNs in two different scales, small and big one, and the DeepFix guys who try to build a VGG network fine-tuned for saliency prediction. And in this table, which can reflect how these two matrices they are good in one of the matrix and bad in others, but they are the top. And the authors of this paper just found out that over 300 images, there's a 10 most representative images that has a very high relationship with all the dataset, and it has a 0.97 Spearman correlation relative to the all dataset images. So all the experiments were did and with those images. And well, let's continue about quantifying where people look, and to further explain how they are doing bad or good. And what they first do is just to using the fixation map, which is the ground truth for saliency model prediction, just thresholding the saliency map with a 95 percentile. And so they just put on the top of the ground truth images and just here obtaining the region of interest, and they obtain a total 651 regions of interest over 300 images, and with those regions, they made two Amazon mechanic crowdsourcing tasks for 20 users. One of the tasks is just showing the region of interest and asking people to assigning the semantic meaning, the one of those labels. And one user can choose up to 15 labels. The other task was just a binary question asking people if the region is looked at by people inside the image. Well, here is an example that how the saliency model are missed. This part and this part are not well predicted. And we have many categories like for many regions. And one of the questions that is asked by the author is what can the model scan if we know that those regions are regions of interest. What they did was just change the saliency prediction and add as the ground truth, part of the ground truth, which is corresponds to the region of interest. Just add the region that the saliency map has previously did wrong. Add this part of the ground truth, and they see that there's a huge improvement in all metrics, more or less, adding the region of interest that they found. And just analyzing category by category, the first one that they found is the importance of the people in the region of interest. And here is showing the number 77%, means that the DeepFix can predict correctly 77% of all the faces appear in images. When images are, when there's a face in an images, DeepFix can predict more or less almost correctly. And let's see when it's doing wrong, the DeepFix model in this case. Just in case the saliency is underestimated when the faces are small, not frontal. In this case, we have a very small face, and the saliency map are more high density in regions that correspond to object and not the faces. In this case, we as a human will only fix on faces of those guys. And this also happens here that we give too much importance to faces, but not to the object in interest. And in this case, they just did a bad prediction just because there's also a face appears in another image inside those images. Is this one of the reasons that it did wrong? However, it also justifies that not all people are equally important inside the saliency, inside the images. That if there's a lot of people in an image, one of the person tends to be more important than others for human when they are showing an image. And what they did is just to assign an importance score to each face. Just print a bounding box over the face, and then within the bounding box they assign the maximum saliency value to that face. If that bounding box is overlapping with the maximum saliency value, it assigns a 1. If not, it assigns a lower value. The maximum should be 1 and the lowest should be 0. And we see that by many experiments that we see that a relative ordering that's assigned by a saliency prediction model does not match with the importance that we as a human give to an image. In this image we can see that people used to fix on faces that stand out from the crowd. In this case, this girl, we give it one that is maximum importance. However, the saliency model always give a central phase that is a maximum score, and however, this hasn't the maximum score as a ground truth. This always happens at here that we are giving the importance to people who is involved in an action. In this case, they are serving a plate. However, the saliency map did it wrong again and not assigning the maximum score to the person who is involved in the action. And another approach was to looking into the text that appears in the images. However, here, and also we should take a look about how should saliency models understanding the text. I mean, here by experiments, they discovered that the description of a warning book is more important than the warning sign here, because people try to understand what is describing in the text, and they are more informative for us. And here's also when they're showing a book in an image to a people, we tend to fix only on the part of the description more than the title of the book. And this is one of the reasons is that when I show you an image with several languages, you always try to watch the one that you can understand. In this case, they have all users from American, so they always fix on the English text. And here we have a justification for what the experiment. In the first, the ground truth, people want to rate what is the description more than the warning sign here. And however, the saliency prediction did just inversely. It's happening the same, that people want to rate what's the description of the book, and however, the saliency prediction gives more importance to what is the title. And here there appears many letters in Japanese or whatever, and people try to understand only the small letter just below this important one, which is only letters in English. Other focus is on object and gaze and action, what is happening in the image, and we see that object of gaze, which means that the object that the people inside the image is looking at, and the action is usually missed by the saliency model prediction. And detecting models and of actions remains a problem for the area of saliency prediction, with the justifiers not doing well this task. Well, here we have our images, and we can see here's the ground truth, and people give a lot of importance to here what is the center of action. However, DeepFix didn't do it pretty well, as what happens also to the silicon. And here we can see that they also did it wrong by predicting the action. Where happens the action? Sorry, and the same here. Well, so conclusion. Let's finish with one slide. So models continue to underpredict crucial image regions, which containing people, action, or text, and so on. And however, that there are regions of greater semantic importance for people in order to understanding human understanding. So, and it also becomes essential for saliency prediction, which can be applied for image captioning, semantic segmentation, and so on. Well, and just to conclude, to answer the question that we formulate at the beginning, how the saliency model began to converge on human performance? So the answer is not yet for the paper authors. And thanks for your attention.
So thanks, Junting, for this very nice talk. Let's see if I can stop.